So hello, so today we're going to be playing CTF. This is from portable.co.il. So the name of the challenge is Guardian 110 points. And here's the description. What you got? You don't know who's trying to attack you. Okay, I'm just gonna download the link for the challenge and just duplicate it locally in my terminal. So let's just unzip. So you can see we're using clip C 2.27. Okay, this is okay. We have the source code, so no need for reverse engineering. We have the binary. Okay, I'm just gonna check the security to see what mitigations are turned on, and as you can see, all of them are turned on, and it is a 64-bit binary. It is not stripped. And let's see if the linkers and okay, they are already applied. First things first, I'm just gonna disable my ASLR to make things a little bit easier for us. Here we go. First things first, let's look at the C file, and we're gonna start with the main function. Obviously, we already know that there will be threads involved because of it. So let's go to int buffering. Init buffering, where is it? Okay, this is just standard for CTFs to make sure the buffers are clean. Okay, Guardian playground. Let's see. First things first, we print a menu. Let me just okay, yeah. Okay, first things first, we print a menu. Here's the menu here. We have create Guardian, speak with Guardian, fight monsters, and delete Guardian. Okay, okay, here's create a Guardian. So first get an index, and it should be between size, which is 16 and 0. Let me try reducing my tab size so this can be easier. Okay, here we go. So as you can see here, we are locating a struct of size, whatever the size of this is. So I honestly forgot what unions are in C. Okay, it says a union in C is a user-defined data type that allows multiple members to share the same memory location. So I'm just in a web browser in my extra monitor. I'm just gonna check what's going on. Okay, union is similar to struct in that it can store elements of different data types. However, struct each member has its own memory. In a union, all members share the same memory, which means you can only use one of the values at a time. Okay, understand it. Obviously, both of these are 8 bytes. This is an unsigned long 8 bytes. This is a pointer 8 bytes. Okay. And we obviously have a what you call an array of this struct. Okay, just generates a random power. get the size of the name, allocate it to a pointer. Okay, and then it prints the name. Let me just see here. I'm just gonna put my comment. So here you can have what you call an initialized data access. I'm just gonna call it this UDA or whatever. An initialized data access. So okay, you can have this if never mind, no, never mind. I was thinking if we enter like your name, we enter the size, let's say it becomes 10, and then you just enter one character, and then you could read the other bytes if they are not the null byte. If there's no null byte, then you can access initialized data. I don't know, maybe we can print a guardian or something. We'll see. Let me just remove this for now. Okay, and then makes us choose a weapon or extra power. Okay, if you choose extra power, just a pointer. Okay, and then read the power. I mean weapon here. And here is extra power. As you can see here, I have a buffer overflow. Keep paste buffer overflow. No, don't, my bad. I thought it was the other way around. I thought it was 20 and next 20. No. So no buffer overflow, my bad. Okay, let's see, the second one is speak with the guardian. Okay, then it's just gonna print some stuff. Guardian name and power. Okay, nothing interesting there. Now fight monsters. So printf choose your guardian. Now you have chosen the guardian. Let's get the fight begin. Okay. The monster health is 1000. Create fighter thread. Oh, I mean fighter routine. Okay, they both look the same as mutex. Okay, how do you want to attack the monster? You enter the index. You enter a weapon. Okay, it now. Delete guardian. Okay, just freeze it. Okay, let's just play around with the binary and just see. Because right now I haven't noticed anything. Okay, this has to name here. I have to put it to my mighty power of 3 and then roll this out. Let's create another one. I should have entered the size. Let's start over. So 0. Start over again. Okay, it is we create a guardian, enter the index, the size, and then the name. So let's speak with let's save it. How do you want to attack the monster? How do you want to attack the monster? So enter index. This is 0, enter weapon. Let me just generate I need to install. I forgot to install Redal. Okay, I won. My guardian won. Here we go. But obviously, that's not our target. Is monster health? Okay. Monster health is what calls a global variable. Obviously, the monster did not restore its health. Let's delete and let's try to find valid index. Obviously, there's no use of the free bug. Okay, let's just start over. We're obviously using mutex, so there's probably no. It obviously has something to do with fixed conditions that I know, because why is this one always why is this one in a loop and this one is not in a loop? Does that make a difference or what? And obviously we're sleeping here. Okay, let me just take a look at this again. Poison now by doing anything like that. Okay, let's try what I was thinking earlier. So oh, I made a mistake. Okay, I was choosing size of 32. My name will be just one letter. Now, I'm gonna free this guardian. I'm gonna release it and then create another one. The same index, doesn't matter. 32, 1 later. Okay, and then now I just wanna try and speak with him. I don't think that worked. Okay, okay, what am I missing? Okay, this function, I don't know, I'm a bit dizzy, but here there's no what you call bounce checking for the index. There's only two, so I think we can do this. Okay, in this function, there out of bounds right overflow. So what we can do is get the TLS canary somewhere there, and you can do something like a return to PLT, and then return to XC and get shell. So okay, let me just try it again in the terminal. So I'm just gonna clear this and run and create a guiding real quick. So let's fight. So you see here, what if we say the index is 10? Now let me try create. You see, here we go. We got a segmentation for it. Okay, I didn't notice this at first. You see, it says invalid index, but it says this after we've already input. Can you see we're in the fighter? Okay, now so we found the vulnerability. Using the fighter routine. Even if it is 2, we're still out of bounds. So let's enter 2 so that we can get to the return. So I'm just gonna run this. I should have pressed okay, doesn't matter. So save name. So now we're gonna fight. I'm just gonna copy this again, and then we're gonna choose our guardian. Our index is 2. What is this exit code? So okay, okay, this is definitely not the thread. If it exits, okay, let's just run this again. If one create, okay, I'm tired of this. Let me just create a script. So I just keep a template of an exploitation script. I'm just gonna use this to do some things. So obviously the name of our binary here is Guardian. Okay, let's leave this pass right now, and let's just come here. I'm just gonna create a class. What should we call it? Guardian, obviously. And then our constructor. Okay, so I just created some lambda functions of response tools, so it can be easier for me. So here are the lambda functions. So something like RL, it is receive line and so forth. So this just makes it easier for myself. Just gonna cast this to a string and then encode it to bytes. That's all. So and then every time, okay, 1 index, 2 index, 3, okay, not 3, 4 index, okay, okay, I just wanna say x is equal to 0 here. So if x is not equal to 0, then we're gonna send the choice. Excuse me. So if x is not equal to 0, if it is equal to 0, excuse me, you're gonna send the index. Also gonna cast this to a string and then encode it. So the first thing is obviously create a guardian. So to create a guardian, we need an index, we need the size of the name, we need the name, and then it is either weapons or extra power. Okay, send the index and then the size of the name. Is it capital letter size of name? Just like before, we cast it to a string and we encode it, and then the name. Okay, I'm gonna pass this as bytes. So okay, before of reference is 0. If it is not equal to 0, then we send 1, and then okay, and then whatever it is there, just wanna cast it to if it is a weapon, then obviously need to be bytes. So just wanna say extra, just like this, else. Okay, if extra go to 0. It is 2 now here. So here we'll definitely need to encode this. Okay, yeah. Okay, okay, now fight. We need the index for the guardian. Okay, guardian, let me just say guardian here. Guard. Then we'll need index. How do you want to? Okay, index. And then you need to enter a weapon. So here will be self.main. It will be free. There is no index, but let me just add this here. Why am I complicating things? Why am I just lazy? So there's that, and then oh, let's not forget that the vulnerabilities here. Okay, I'm gonna create the other methods later. So we just create one. At index 0, create at index 0 size in the name. Okay, here it is. What is I should just change this to a list. So now I'm just gonna fight index 4 and so that's it. So this now should give me a sick fault or something. Okay, maybe not. That's why it was 10 before when we got a sick fault. I think maybe I might have done something wrong. Yeah, do you prefer extra power or web prone? Let's try, let me run it with the TDP option. Just gonna split my terminal and show GDP server here. So here it is extra power. Okay, I see. Should be extra power here. Let's try again. Oh, I see. Should be fight. Let me just put a pause here. Okay, here we go. Let's try again. Okay, just setting valid index. What did I change? Okay, there's something I need to check. About the TLS. Okay, so since we're using threads here, so let me just so 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 this is what I'm doing. Let me find the offset to what to call okay, this is what I'm gonna do. I'm just gonna put some breakpoints. B vital routine plus. Let's just check. So where do we create the array of weapons? Just after we print, use puts, then print. There's somewhere here. So I'm just gonna plus 106. I'm just gonna put a breakpoint here. And let's try running this again. Okay, I'm not quite sure what went wrong. I see where I did it wrong. Okay, you see, now this is what we have to do. Just gonna say that much. Let me just video reduce this. So RPP. Let me change this to 0 and then 1. Okay, so RSP is here right now. So obviously you're gonna use a lot here. So RPP is so EEF. Here's RPP. This means this is what you call my return address. But no, here's the canary. So here's the canary. So here is my return address. So let's just calculate this. Just gonna spawn a Python interpreter and then to obviously here I should put a a breakpoint just after it reads. Just like that, let's start again. Breakpoint, so registers. Here we go. Next registers. Okay, here's how we're gonna do this exploit strategy. So as I said here, you're gonna use the out of bounds right to override the TLS canary, and then use a return to a PLT to get the libc leak, and then return to libc. We get a system and execute with bin sh to get a shell. So so let me just put it in order here. So we just wanna fight override TLS canary to does it quit? There's something I need to check. It says exit here, so I think we're gonna have some trouble, but we'll see. Then we're gonna fight again. This time it will return to PLT. Just wanna call puts.plt with puts.port, and then delete the address, and then we're gonna fight again, and then now we do a return to libc. So now we will be we'll try to call libc system with the address of bin sh. So that's what we're gonna try to do. So let's see. First things first. Let me try this. B8 plus okay, let me run this one last time, and then what I'm gonna do with it, I'm gonna try to find which index I should use to get the canary, TLS canary. As you can see, so obviously okay, So let's see where I think I'm gonna end here because the kids playing outside are really making a noise. I'm gonna try to continue. Thank you.